All right, so let's do 6. All right, so we have, this is calcium metals added to water, right? Yeah, okay. So, so here we have our calcium metal, and so it needs to be solid. It needs to start at room temperature, so solid. We can't say that it's dissolved. Plus H2O. Okay. And does it tell you what we form? What does it say?
It just says calcium metal was added.
Okay. So what we do is you assume that it's going to be like a single replacement reaction and that water behaves like an ionic compound. Okay? So you could instead write your H2O as HOH, still keep it as liquid, and that will help you visualize the single replacement reaction. So now here I have calcium hydroxide, and calcium is a 2+. Now calcium hydroxide is soluble. On this one, on this chart, it has it as soluble. I don't know, it's not as comprehensive on your data booklet sheet, so I don't know why there's incongruencies.
I think we wrote that in.
Did we?
Yeah.
Okay, good. Okay. So it should be aqueous. Okay. And then what's left over is H. But when H is all by itself, what does it need to be? H2. So it's a gas. So we have H2 gas. All right. So now here, let's expand everything. Oh, I need to balance it. Jeez. I'm gonna put a 2 there, right? Yeah, and that's it. Okay, so now we have our calcium solid. We have our water. Now, you know how I said we leave water alone because it's a molecular compound? Since it behaved as an ionic compound, we're going to break it up. Okay? It was involved in a single replacement reaction, so it behaved ionically. So, and this is a bit advanced because we say that water actually does ionize. So it's just a very small amount. So let's put here, we have 2H plus aqueous plus 2OH minus aqueous gives us Ca2 plus aqueous plus 2OH minus aqueous plus H2 gas. Okay? And if you get stuck with something like that in a test of where you need to break water down or not, I'll help you with that because that is advanced. Okay?
Why are they, okay.
Yeah, go ahead.
For like the 2OH on top, you have it as liquid, but then you have it as aqueous.
Because since I'm treating it as an ion, it can't be an ion liquid. It's like an ion is dissolved. Yeah. Okay, so is calcium the same on both sides? Nope, so I need to keep that. Is H plus the same on both sides? Nope, so I'm going to keep that. OH, is it the same? Yes, so I can cross that one off. So now we can rewrite it. So we have our calcium solid plus 2H plus gives us Ca2 plus aqueous plus H2 gas.